Okay, so I want to go back to this property, which sounds so tempting. Um, Now, the point that I want to make is about the for all quantifiers. So this is for all rows. What does that mean? So can row, for example, be equal to 1? Yes, we're talking about the first row. Can it be equal to 2? Yes, we're talking about the second row. Can it be equal to 1.5? No, there is no 1.5 row, okay? Can it be equal to minus 12? No, it can't be equal to minus 12. So whenever we use quantifiers, we always have some kind of an idea of what all the possible values of the variables can be. And we call this the domain of discourse. That's an important phrase. So domain of discourse, what that means is, what are we talking about? Okay. So when I say for all, I mean for all integers. Right? In this case, right? Because I can't have things like fractions, 1.5. I can't have things like irrational numbers, like pi. So I'm only talking about integers. That's all that we're discussing. Okay. Now, even that's not quite enough because, for example, how about integers like r is equal to 5? No, we can't do that because it turns out that we only have 3 rows. Okay. How about time is equal to 5? Yes, that's actually okay, right? Because there's 9, or actually 10 different time slots from 0 to 5. So how about time is equal to 12? No, that's beyond our domain of discourse. That doesn't apply. So there's really two kinds of things that are happening. So the domain of discourse, the first thing is it gives us some sort of a rough type, and that could be something like the integers. And then we have some kind of limits, okay? And that could be 1 to 3, it could be 0 through 9, or something else, right? That we're not discussing yet. But the point is that we have possibilities, and what we want is to be able to say this is true of all the integers, only the interesting ones. Now, how do I specify these? Okay, so the rough type, what we're doing is we're thinking of some kind of a large set that everything comes from. So, for example, x must be an integer, and there's 3 different ways that we routinely do this. The first one is just implicit. And implicit means that we don't mention it, right? We just know that we're talking about the integers. And so, for example, we might say for all x, and then some kind of property, x minus 2 plus 2 is equal to x. That is actually true, okay? It is true of all the integers. Here's another possibility, okay? It can be explicit in the quantifier. And I won't use this very much in this class, if ever, actually, but it's fairly common. You can say for all x, and we write it like this, okay? And we're going to talk more about sets in the next module, but what this means is that x has to be an integer, okay? That capital Z is just kind of standard mathematical notation for all the integers. So what it says is for all x that happen to be integers, x minus 2 is equal to x minus 1 minus 1. Okay, and here what we're doing is we're changing the quantifiers so that the quantifiers is very explicit, only applies to integers. Okay, you'll see that a fair amount. Now the other idea is to make it explicit, but in the property. So then you would write like this instead: for all x. I notice that's just a for all x now. So again, we have the question: what kind of thing can x be? But then we'll make it explicit by actually putting that in the property. So we'll say x belongs to the integers. And like I said, that's just the mathematical notation that says x is an integer, and we'll talk about that later. That implies that x minus 2 plus 2 is equal to x. Okay, so those are 3 ways that we take care of kind of the rough type of the variables. We can be implicit. Hey, we're talking about integers, don't forget. We can be explicit for all integers x. This must be true. And then we can be kind of explicit with but with implication for all x. if x is an integer, then this is true about x. So that's how we handle types. Okay. Now, what about kind of the more fine limitations? So, for instance, for all rows, some property is true. Okay. Well, the rows must be between 1 and 3. In fact, they can only be 1, 2, 3. So how do we do that? Basically, two approaches that we tend to have. Approach one is to use implications. So I'm going to write it like this. For all row, and I want to be clear that I'm talking about the integers, so I'll say belonging to the integers. Okay. But then my condition looks like this. Um, r is greater than or equal to 1 and r is less than or equal to 3. That implies that something, right? So notice that this is the limits, the possible values of r. Okay. Now the other approach, the other approach is a little nuts, all right, but it's really really useful when you can do it properly. And what we'll do is we'll just have the notion of defaults. Okay, and this is implicit, meaning that you and I just agree on this, and then we take advantage of it. So what we're saying is that x must be 1, 2, or 3, and we're going to assume, okay, this is the default part, that any other value means 1. Okay, so we'll say for all r, and then some property here. Okay, now let's suppose that r is equal to 2. Well, then we're talking about the second row, no discussion. R is equal to 3. We're talking about the third row, no discussion. R is equal to 1. We're talking about the first row, again, no discussion. But let's suppose that R is equal to 50. Well, there is no 50th row. So what we'll do is we'll just treat this exactly as if you had said R is equal to 1. That's crazy, right? But it's so convenient. And why is it convenient? Because you don't need to keep writing this implication all the time, right? You just simply assume that. Oh, R is always going to be between 1 and 3. And if you happen to give me a value that's different than that, I'll just assume that it's 3. So let me give you some examples, okay? Let's say that we're talking about the property of being odd. Okay? Now, we're only going to talk about integers. Okay? So we do not have to worry about odd of 1.3. Okay? We don't have to worry about that because 1.3 is not an integer. Okay? But one thing that I do want to worry about is that I want to restrict myself to integers in the range 1 to 100. Okay? And my default is going to be 1. Okay, so this is kind of the understanding. Okay, this is like a gentleman's agreement that we're going to have, that this is the only thing we're going to talk about. Okay, so what exactly is odd of 3? Well, that's true, right, because 3 is an odd number. How about odd of 6? That's false. 6 is not an odd number. How about odd of 100? That's false because 100 is not an odd number. How about odd of 101? Well, that's tricky because 101 is outside our things. So what we'll do is we'll treat it exactly as though we had said odd of 1. This is true. And you know what's coming. How about odd of 110? That's true. And why is that true? Because we're going to treat it as though it was odd of 1 because it's outside our intended range, and odd of 1 is true. So that's a convention. I find it useful sometimes when I'm writing programs, right? Because when I'm writing programs, I can say this thing accepts a string, but there's no way for me to say, oh, but the string has to have at most 8 characters in it. Okay, so what happens if you give me a string that has 10 characters? I can throw an exception, right, which then you have to handle. I can just fail, in which case you have to deal with it. Or I can simply take the convention that says, look, if they give me a string that is not valid, then I'll just pretend that the string that they gave me was equal to A, B, C, D, E. Okay? Maybe not the best default value, but you can see the pattern. So I can do something like that. It just makes the interactions between my code and your code a little easier. Okay. Um, in some further lectures, we're going to take advantage of default values, and you're going to see that they actually make the descriptions a lot smaller. I'll let you decide whether it's a good idea or a bad idea, but just be aware of it. It's convenience more than anything else.